Alright, so we have our jumping and everything. What I want to do now is do something very cool, and something relatively simple. You can see if I now jump, he is changing the position, yeah? The pelvis is rotating up and down. Not just that, I can also switch the direction and he's like turning into this direction. And this already gives it a lot more feeling to it. You can see if we're jumping down, he's like going down, and I can like... So this will give us a lot more feeling. So in order to do that now, we need to go first of all to the UnMVP, the one which has a little bit of an event graph logic, where we ask if it's an error, and the other window here where we have the state machine, right? So two things. First of all, in the enum graph, I wanted to go inside the state machine, inside the jump. There's where we are going to handle the animation logic for the jumping, obviously, because this is inside the jump, right? And the first thing we need here in order to modify a bone. Now, we might do this later with a control rig, we'll see, but I wanted to show this as well. One way is to use the control rig, and the other way, the old way, is to just right click here and under skeletal somewhere. I could type it in, but I want to show you the option here, skeletal control nodes. You have a lot of nodes that allow you to modify bones. And what we want is a very simple one. We want the transform modify bone. It literally just lets us transform a bone. And we're going to grab this human here and plug it in and plug this over here. And you get also some converters. Now, if we select this here, we can go over here and we can change a few options. First of all, bone to modify. We want to modify the pelvis. And then you can see the translation, so the position, the rotation and scale all are ignored. Currently, we cannot deform them anyway. So we want to use the rotation. And we want to, let's use replace with existent for now. And we can just type in a rotation of 60 or something. Let's hit compile. And we're not going to see anything because this is currently not triggered. If we go down here to the anim window and we check is an error, you will see now he's jumping, but because we rotated it, let me change it back to 0. You can see how he's rotating, right? Currently we're replacing with existent, but what we want is add to existent. We want to modify the existent one, so we want to add to it. And then we can modify this a little bit. Probably not X, not yet. What we want is probably like Y. No, also not. Yeah, probably X for now. Minus 50 or something maybe, and you can see he's looking up, right? But we obviously want to do this with a value or something that is changing. Also, you can see we're using component space. This means like, I guess it's world position or something, or the position of the whole skeleton, but what we want is relative to the bone, so that we're actually using the bone axis. We can see the bone axis. If we go down here into the skeletal mesh and select the pelvis, you can see where the axes are pointing. So now, this is why I was a little bit confused there. If we use Y, because Y is looking over here, yeah? If you want to rotate around Y now, let's say 15 or something, he's going to look more up. All right, let's put it down to 0. And that's all we need for this node here. So first of all, we need some logic. What we plug in here is just a rotation result. We don't need much more here. First of all, we need to sort out the logic, and we do this in event graph. And this is relatively simple. I just took some time, figured this out, thought about it. It's just how we do it. We're going to grab the velocity here and make a reroute and drag this over here, make another reroute. And all we need is drag this out again, make a break vector. All this does is break the vector into its individual axis. And all we need is the Z here. Now, how do we get the Z from here into this window? By just storing it in a variable. So we can just right click this here, promote to variable, and we get a variable down here. We could also just press plus here, doesn't matter. And we call this rot underscore pelvis up. Now we obviously want to set it, so we change the value with the, let's plug this in here, with the velocity. That's all we need here, and we can hit compile. Now we go over to the dark creature anim graph here. We can grab the rod pelvis up, get it, and we want to plug it only into one rotation. Which rotation? The one that's rotating up, which is Y. So what we need is make vector. Make a vector. Quick side note here, you can also right click this rotation and split pin structure, but for some reason this doesn't work. Okay, so I don't recommend you doing this. Actually, not make vector, sorry, because it's a rotator. We need a make rotator. Okay, and now we plug this in. It's essentially the same thing as splitting it, but for some reason splitting sometimes doesn't work. A little bit buggy. And which axis do we want to use? Like I said, we want to use Y, so we're just going to plug this into Y here. And if we now hit compile and we run around and we jump, you can see he's going crazy, right? Wee. But essentially he's rotating when we jump, and this is what we want. Essentially it's just way too strong. So what we can do is just grab out the pelvis here, and take a multiply, float times float, and we plug this in here. And we're going to just make this far weaker. What I used was like 0.05. And now compile, and let's take a look. And you can see he's doing what he should. So when we jump down here, you will see he's going to rotate and rotate and rotate. Actually, he's stopping for some reason. Okay, interesting. Yeah, because we don't get more velocity. But we can clamp this. So all we need to do is, well, clamp it. Drag it out, clamp. And we want to clamp a float. So plug this in here. And what do we want to clamp it with? We want to clamp it between -90 and 90. Why? Because the maximum rotation he should have are 90 degrees, so up or down. We hit compile. If we now run around, he's still doing the same thing. And if we jump down, you will see he's stopping at 90 degrees. Perfect. So let's solve that thing. So we should probably sort this a little bit out because we have here the rod pelvis upright. I want to select this. And over here we have categories, and I'm just going to put this into the category pelvis rod. And you can see it gets its own section here. We can fold this in and fold this out. Now the other thing, we want the side bending. So if we jump to the side, right, so he's like bending and rotating around, not just being straight all the time. This is a little bit more complicated. For that, we have to go into the blueprint because we have to sort our logic there. So in the blueprint here, you can see we have this event tick. This event tick we didn't use yet. It's basically ticking every frame. It's very expensive to use this, but we won't get around this. So the first thing we can do here is we want to grab this out, or actually just press B on your keyboard and left click. This will create a branch. Now we can plug this in here. And you can see this has a red dot and a true and a false. So we can just simply put a condition in here when this should be true and when this should be false. And we're going to do this very simple. We did this before. We're just dragging this out here and we're asking is falling. And so this only triggers when he's actually falling, and we are not ticking this every frame. Yeah, and it's getting a little bit better. Now, first of all, we want a value which we can put over into the anim here, NMBP. So we're going to create a value. Let's click plus here and we call this turn rate. Now currently it's a boolean, you can see it's red, and up here it's a boolean. We want a float, just a number, and we can hit compile here. We're also going to put this into the pelvis rod right away. So this is nicely sorted, and we're going to drag this out here and we are going to set it. So then we can just plug this in here and we would have a value which we can set. Now things are getting a little bit more complicated. First of all, I want you to follow, then we can explain it. I want to get actor right vector. All this gives us is the right vector of our capsule. So if we take a look at the viewport, it gives us the right vector. So this one here. And we can use a dot product, which sounds familiar maybe. And we can plug this into the turn rate. What we're going to do here is we're going to compare the right vector to the forward vector. So we can, for now, get actor forward vector. There we go. Essentially what we're doing is asking how much does the right vector with the forward vector overlap? And the answer is never. Maybe a little bit here on the side. So you would get like a little bit of a side value here or something. But they're not overlapping. They're not changing. They're not dynamically or anything. So in order to do that, we need to get the forward vector of the last frame. So how are we doing that? Let's delete this forward vector. We need on the next frame to set the forward vector. So we need a new variable. Let's click plus here and we call this store forward vector. And now since this is supposed to be a vector, it can't be green, it needs to be yellow. So it has 3 values, a vector. And we're going to drop this into the pelvis rod and drag it out and set it. And we want to set it with the get actor forward vector. So what we're doing here is, first of all, we set the turn rate by this here, whatever. And in the next frame, because this ticks later, we're going to set the forward vector and store it here. If we now get our stored forward vector and place it here, we essentially, what we do is we set this here. Yeah, first frame, it will not overlap because forward is forward, right is right. And in the next frame, we're storing it. And the next frame, we're going to compare, because it's ticking again, right? It's coming here in again. We're going to ask the forward vector, the current forward vector, with the already stored forward vector from the last frame. So meaning, if we turn in a circle and we're comparing the last right vector with the forward vector, it's going to move in. This is a little bit more complicated, but think this through because this is a very typical thing to do to store the last frame of something and compare it. And now let's print this out so we can actually see what's happening. So let's use a print string. And what we want to print is not this one here, because this is only thing that does is store it and give it back here. What we're actually going to use is the turn rate. So let's plug this in here. Let's just see what we get. So run around a little bit. We're not getting anything. Why not? Because we're not jumping, right? For the moment, let's skip the branch here so we can always see everything here. And you can see here, we're getting a value. If we don't rotate, nothing will happen. But if we rotate, we get a minus to the right. If we rotate to the left, we get a plus. Take a close look. Minus, plus. And with that, we get already the direction we want. So if we rotate to the left, we have a value which we can use to rotate the pelvis. If we rotate to the right, we have a value we can use to rotate the pelvis. And we want this only in the jump. And now we want to get this turn rate into our unMBP, so we can use it to offset stuff, right? In order to get it into our unMBP, I think I'm going to move this a little bit back here. We have to, first of all, grab it from the blueprint. Because we don't have this value down here. You can see those are different things. So in order to get it, we have to use something very confusing and dumb named cast to dark creature BP. It's actually not casting to, it's more like casting from, but it's really confusingly named. And then we have to get the object here. We have to specify the object. Try get pawn owner. There we go. Try get pawn owner. We can plug this into the object. With that, it knows where we want to grab the variable from. If we now drag this out here, make this context sensitive again, and we want to get the turn rate, you will see we don't find the turn rate. Oh, actually, there it is. Make sure you compile this here first. Otherwise, it doesn't know there's a turn rate. So let's get the turn rate. Get the turn rate. So now we have it in here, but we cannot still not grab it down here. So we have to set a new value. So make a new variable, and we're going to also call this turn rate and make this to a float as well. Not sure where this error is coming from. And we're going to plug this into the pelvis here as well, into the pelvis rod section, and we can drag this out here and we can set it. So basically what's happening is we are setting the turn rate over here in the blueprint, right, with the logic we want. Then we go to the unMBP, we cast it from the blueprint, we get it here, and so we get it down here. We just simply have to set it again with a new variable. Now we actually have the variable of the turn rate down here. Now we can just compile here, and we can go to our unMBP here, graph, and we can grab this turn rate, get it, and we can plug this into the role. Now it's going to be probably very weak. Let's see, a little bit. We can make this far stronger by just multiplying it. I think maybe like a 50 or something. Let's see. To the x. Why the x? Because the actually might be, yeah, it's x because like the x will rotate around. Yeah, the right one will rotate around. So let's see. Still very weak. I think I used a 500 or something. 500. All right, let's see. And there we go. We're rotating it around. Now, two problems. First of all, we're rotating into the wrong direction. And second of all, it's very jittery. Don't worry, we can fix this. First of all, the fact that it's the wrong way around, we just simply have to flip the value. So we can just use another multiply here. Multiply. And we could just multiply as -1 and it would flip around. But instead, to get this a bit more straightforward, we can just put a minus in front here. We're going to do the same thing, -500. And if we now hit compile, we're going to at least rotate into the right direction. Yeah. How do we get rid of the jitter? We just simply have to interpolate it. For that, we go back into the dark creature blueprint where we store the main logic. So how do we interpolate this? Now there's a thing, there's a R interp. This is R for rotation interpolation. We don't need this. We don't have a rotation. There's a V interp. This is for vector interpolation. We don't have a vector. We have a F interp for float interpolation. And we're just going to use the F interp 2. That is one that usually works pretty nicely. And what we're going to do is we're going to get the turn rate, get it, and the current turn rate to the new target turn rate. Because this is the one from the last frame basically. And here we're going to get the new one. We can just plug this in here. So the other two options here, the delta time is just a value the game engine needs in order to interpolate. And all this is delta world seconds. So basically kind of the play time. Yeah. So it knows how fast it's interpolating kind of. You just simply have to plug it in. There's nothing really to worry about. And then we have the interpolation speed. 0 will be very slow, I think, or 0 will be off. I think 0 will be off. Lower numbers will be very slow and higher numbers will be very fast. So what I used was a 7.5 that worked pretty fine for me. And we can just simply hit compile. And now let's take a look if this works. And we can see it's working pretty smoothly. It's nicely interpolating and we're falling down and we can rotate if we want to. And with that, you already get a lot more feeling when it comes to like playing around with your character. So one last thing though, in the UnMVP here, you can see we didn't clamp the turn rate. I think it's good to clamp it just in case. I mean, you would need to somehow get a very high rotation value to actually break this, but just in case, we're going to rotate it. I think 90 might be a little bit high, so let's go with like -50 and 50 and hit compile. And with that, that is off. Now we should probably clean up some stuff. Let's start in a blueprint here. We're going to drag this all nicely together here. We can name a few things if you want to. Probably best, especially as beginners. See only when falling. This here is going to be interpolate for smooth. Compare last forward with current right. Can delete the print string here. Store forward vector. And this is just simply where I set the turn rate. And then we can probably make a main frame here. And we call this pelvis rod for jump. Alright, and we got this solved. Let's take a look here. We stored our values nicely in a pelvis rod. Let's go over to the UnMVP, to the event graph. Take a look here. We should probably clean this up here a little bit. Let's make a frame here. We call this get velocity, set walk, or get walk speed actually. Get walk speed. We might set a variable there, but we're actually just getting it in order to drive our animations. Jumping bool. The reason I call this jump is because you might fall somewhere down or something where you don't actually jump and then you still isn't falling. Just a side note here, maybe we want in the future somewhere to add a few variables there, because you can just drag out here and type an end and you will get like an end boolean, and you can combine different booleans in order to achieve this one to flip to true. Not important right now. Now over here we have pelvis rod up, and here we have pelvis turn rate. And we can compile. Everything should be nice and dandy now, but it seems to work and this is pretty nice.